In today's lab, we will consider the following questions. What happens to objects in freefall? And how do mass and air resistance affect acceleration in freefall? We will explore these questions by measuring the acceleration of different objects in freefall and seeing how they compare to each other and g.
To begin exploring these concepts, let's look at a simple example.
If we drop a sheet of paper and a crumpled up piece of paper above a table, which will hit the table first? What differences between these objects will affect their acceleration due to gravity as they fall? Let's drop them and see what happens. The ball hits first, but why? Let's take another look, first focusing on the motion of the ball. In the ball's case, we will neglect air resistance. This is only an approximation. The only force we draw is the force of gravity pointing towards the Earth. The ball then moves with a constant acceleration, and this acceleration is independent of the mass of the ball. Now let's look at how the position, velocity, and acceleration of the ball change over time. Under constant acceleration, the position is quadratic and the velocity is linear. We also saw a case of constant acceleration with motion on an incline. Now let's see how the motion of the sheet differs from that of the ball. For the sheet, we have to include the air resistance. This air resistance points in the opposite direction of the motion of the object, and is roughly proportional to the velocity of the object at low speeds. The sheet does not move with a constant acceleration. When the magnitudes of the air resistance and the weight are equal, the acceleration is then zero. This is called reaching terminal velocity. Let's look at how the position, velocity, and acceleration of the sheet change over time. At t equals 0, we start with no air resistance as the ball is dropped from rest. The acceleration is just the acceleration due to gravity, g. As the magnitude of the velocity increases, the air resistance increases. This causes the magnitude of the acceleration to decrease. We reach terminal velocity when the air resistance and the weight cancel each other out, giving us zero acceleration. The velocity is then constant while the position is linear. You will use the spark gap timer to measure the acceleration of the brass and plastic cylinders in freefall. You will then attach the plastic and brass discs to these cylinders to measure the effects of air resistance. The spark gap timer works by burning marks in the paper tape at a frequency of 60 Hz, or 60 every second. After you've connected the power cord, hold down the white button during measurement to burn marks on the paper tape. Make sure the tape is aligned in the spark gap timer, and hold the button down during your entire measurement. Note the burn marks on the tape, especially the darkest one on the right where the measurement was started. To measure the acceleration of the cylinders, you will have to attach the paper tape to the cylinder. Fold the tape to create a thicker portion for the cylinder to grip, insert in the cylinder, and tighten. To measure the effects of increased air resistance on the acceleration, you will attach a disc to each cylinder.
Open the cylinder to insert the parachute and tighten.
When you are ready to take data, center the tape in the spark gap timer. Make sure the piece of tape is long enough to reach the floor. Check that the foam is below the timer and release the cylinder. Be sure to hold down the white button while recording your measurement. Now let's take a look at the tape from that run. The pink circle shows the start of the measurement. The dots in the white circles are all the marks from the spark timer. As the cylinder accelerates, the spacing delta x between the marks increases. Measure the distance x from each mark to the first mark in centimeters and enter these values as a column in Excel. We will then use Excel to calculate the velocity and acceleration.
Column A has the position measurements from the tape in centimeters. We'll write an equation to convert these measurements to meters. Enter your equation starting with an equal sign in the first box of the column where you want the equation to apply. In this case, we want to divide the first column by 100. The equation we type in box B2 is A2 divided by 100. Press Enter and drag the corner of B2 to select the whole column. This will apply the equation to all the values in column A to populate column B. Follow the same steps to write equations to calculate the distance between subsequent measurements and the velocity. You also need to make a column for the time. The spacing between the entries should be the period of the spark timer. Once you have calculated the velocity and time, apply a linear fit to a velocity graph to find the acceleration. Compare the accelerations for the 4 cases, both cylinders with and without parachutes. What can you say about the effects of mass and air resistance on acceleration in freefall?